Hello, everybody. Happy Monday. Hope everybody's feeling good and ready to do some work on fraction division part 1. At the end of this lesson, I'm hoping that you can say, I can use visual models to divide unit fractions by whole numbers, and I can apply and extend previous understandings of multiplication and division to multiply and divide fractions. Let's get started with a quick warm-up. In this warm-up, we'll be solving fraction of problems. You'll remember these from your work on fraction multiplication. 1/3 of 1/2. What does that equal? Oh yeah, 1/3 of 1/2 is equal to 1/6. Let's take a look at a visual model, an area model, that explains why this is true. Okay, let's take a look at why 1/3 of 1/2 equals 1/6. We'll have this rectangle represent the number 1. We're not working with 1, we're working with 1/2. Let's take that rectangle and cut it into 2 equal pieces and talk about one of those pieces. That's the fraction 1/2. What are we doing with that 1/2? Well, we're finding 1/3 of it, so let's cut it into thirds. So each one of those pieces is going to be 1/3 of 1/2. That piece, and that piece, and all the pieces that we need to fill up one whole. And there's 6 of them. So each one of those pieces is 1/6 of the whole. There's 1/3 of 1/2, and it does equal 1/6. Okay. So now let's take a shot at these other two. You can pause the video while you work out these other two, and then press play and come back. All right. 1/4 of 1/5. That's 1/20th. And 1/2 of 1/4, that equals 1/8. We're noticing that to solve fraction of problems, we just have to multiply the numerators of the factors to find the numerator in the product. And we multiply the denominators in the factors to find the denominators in the product. It is that easy. Let's take a look at a couple more. Again, you can pause the video and then just solve the problems and then press play to come back. Okay, 2/3 of 1/2. That's 2/6. And 3/4 of 1/5, that's 3/20. And 5/6 of 1/3, that equals 5/18. We can see the pattern continuing of multiplying the numerators in the factors to find the numerator of the product, and just multiplying the denominators of the factors to find the denominator of the product. Here's another quick set. Pause the video, come back once you've solved them. Okay, 3/5 of 5/6. Well, 3 times 5 is 15, 5 times 6 is 30, so that's 15/30ths. And we know from our equivalent fractions rule that 15/30ths is equal to 1/2. And how about 2/3 of 3/4? Well, 6/12 is also equal to 1/2. 4/6 of 3/7 equals 12/42. Let's take a quick look at some division vocabulary. Dividend. That's the number in division that is being divided. For example, in 35 divided by 5 equals 7, the dividend is 35. The divisor. In division, that's the number that divides another number. So in 35 divided by 5 equals 7, The divisor is 5. And the quotient. The quotient is the result of dividing one number by another number. So, for example, in 35 divided by 5 equals 7, the quotient is 7. It's the answer to the division problem. Here's a few examples that show it using different division notations. Now it's time for our math message. We're going to solve these problems, and we can use a drawing or number line to help us think. First, a 6-meter rope is cut into 3 equal pieces. How long is each piece? Number 2, we have a 1-meter rope that's cut into 3 equal pieces. So how long is each piece? And number 3, we have a 1/2 meter rope that's cut into 3 equal pieces. How long is each piece? Pause the video again and take the time to solve these 3 problems. Okay, let's talk about some solutions and strategies for problems 1 and 2. Well, what number models could we write that would summarize our solutions to problems 1 and 2? For number 1, we had a 6-meter rope that was cut into 3 equal pieces. How long is each piece? Well, 6 divided by 3 equals 2, so each piece will be 2 meters. Here's number 2. A 1-meter rope cut into 3 equal pieces. How long is each piece? Well, that's 1 divided by 3, which equals 1/3, so each piece will be 1/3 of a meter. Why does it make sense to use division for these problems? Well, it's right here, isn't it? We've got the rope, and we're cutting it into equal pieces. So we're dividing it. That's when we use division. So here we go. Let's think about these problems a little deeper. How is problem 3 similar to problems 1 and 2? Well, we see that in all of those situations, we're taking a piece of rope and cutting it into 3 equal pieces. Well, what's different about number 3? Well, I bet you noticed that in number 3, the length of the rope is a fraction. So in number 3, we are dividing a fraction by a whole number. So what would the number model be for number 3? Let's write a number model with a letter for the unknown. One half divided by 3 equals P. In this case, we're using the letter P to represent our unknown quotient, the length of the piece of rope. Let's practice those vocabulary words again. In each number model, let's identify the quotient, the dividend, and the divisor. 6 divided by 3 equals 2. I've color-coded them to show which ones they are. So here in 6 divided by 3 equals 2, our dividend is 6. Our divisor, the number that we're dividing by, is 3. And our answer, the quotient, is 2. And in 1 divided by 3 equals 1/3, our dividend is 1, our divisor is 3, and the quotient is 1/3. In these two examples, how does the quotient compare to the dividend in each problem? Well, in both of these problems, where we're dividing by a whole number, our quotient is a smaller number than our dividend. So do we think that the quotient for problem 3 will be less than the dividend? Oh, how do we know? Well, we think it's going to be smaller because we're taking something and we're breaking it up into equal pieces, and we're figuring out the size of each one of those pieces. So of course it's going to be smaller. When we predict the size of the quotient compared to the dividend, that's one way to judge the reasonableness of our answers. Okay, so let's think about some solutions to problem 3. Here's a number line. We're going to represent the length of the rope first at 1/2 meter. But since we're dividing it by 3, we're going to break that up into 3 equal pieces. And then it's time to think. What would one of those pieces be called? Well, there's 3 pieces that make up 1/2. So there'd be 3 more pieces that make up another half to get a whole meter. So each piece would be 1/6 of a meter because you would need 6 of them to make the whole meter. Dividing the rope into 3 parts is like finding 1/3 of it. So we're trying to find 1/3 of 1/2 of a meter. 1/3 of 1/2 is the same as 1/3 times 1/2, or 1/6. Let's take a look at an area model that shows us why 1/3 of 1/2 is really the same thing as 1/2 divided by 3. Okay, let's take a look at an area model for 1/2 divided by 3. Again, we'll have the rectangle represent the number 1. And we're not working with 1, we've only got a half. So let's take that whole, break it into 2 equal pieces, and talk about one of those pieces. That's the fraction 1/2. And what are we doing with 1/2? We're dividing it by 3. And each one of those is 1/2 divided by 3. And how many of those pieces are there that make up the whole? Well, there's 6 of them, so each one of those pieces is 1/6. That 1/6 is 1/2 divided by 3. So we've seen a few times that 1/2 divided by 3 does equal 1/6. Does it make sense? How do we know? Well, 1/6 is smaller than 1/2. And also, another way to check your answers to a division problem is to think about the relationship between multiplication and division. We solved problem 1 using 6 divided by 3 equals 2. We can use multiplication to check that answer. If 6 divided by 3 equals 2, we can take our quotient, multiply it by our divisor, and we get our dividend. The relationship between multiplication and division can also be used for problem 3. So if we want to check 1/2 divided by 3 equals 1/6, what would we multiply and why? What product should we get? Well, we'll take our quotient, 1/6, multiply it by our divisor, 3, and hope that we get the dividend 1/2. And in this case, 1/6 times 3 equals 3/6, which does equal 1/2. 1/6 times 3 equals 1/2. What does this tell us? Well, it tells us that we use the number line, an area model, and the relationship between multiplication and division to solve and check a fraction division problem. So we can look at these learning targets and truly say, I can use visual models to divide unit fractions by whole numbers, and I can apply and extend previous understandings of multiplication and division to multiply and divide fractions. Thanks, everybody. Have a terrific day.